Oh, look, I forgot the local recording, but it's all good. Can use the cloud recording. Yeah, we already have 4 folks. Welcome. Hey, folks, welcome from wherever you're tuned in from. So, yeah, tell us a friend, even if they never signed up, tell them it's available on YouTube. They can tune in. So let's run the countdown. Yes, welcome from wherever you're tuned in from. Today is a webinar. We're gonna do it a little bit different from the normal live or BB live sessions. So this is our first time, so bear with us if anything goes wrong. It is as planned. So I'll quickly hand over to Dorcas, who's going to take us through the session. So the idea of the session is a follow-up from the live session we did with her, where she was talking about her experience working with on the Linux kernel. Today, she's gonna like delve now deeper into the work that she did, and also just to get you an idea of how you can get started if you want to go that route. We'll try to start out from the basics as possible, but there are things that we already assume, but don't feel excluded if you're not yet there yet. We just assume basic knowledge of C. If you haven't learned C yet, don't worry. You can easily. It's a language that is easy to pick up, and so that only that and a bit of some knowledge of working with Linux, just not even super admin, sysadmin level. Yeah, that's all that we expect from you. And I just thank God that this is the age of LLMs. By the way, you can learn a lot from the GPT. If you have any questions, like you can just ask, like, hey, how do I set up this? Sometimes it gets something wrong, but it's not really far from the truth. You can always work around the answers that it gives. So yeah, I see we have 6 folks online. I'm not entirely sure. This is the first time using this platform. I'm not entirely sure if the 6 people online are the ones who signed up. Someone can't get I'm learning this UI on the guest list. But don't worry, if you're there, just post a comment that tell where you're tuned in from, if everything is good, if my sound is good, and also if Dorcas sound is good, let us know. If you're curious about the animation there, it's something called ASCII Aquarium. Aquarium, it's a terminal animation thing. You can look it up. Just put it there for as a filler. Yeah, but now I would like to hand over to Dorcas. Welcome, Dorcas.
Thank you. Hi, everyone. I want to know if the sound is good and you guys can be able to hear me. Okay, thank you. So, yeah, this is just a follow up from uh, what we did before. Before we start, Nanda normally gives you 15 seconds to subscribe, and he has forgotten today. So, in case you have not subscribed, it is that time for you to subscribe right now. So I'm giving you 15 seconds for you to subscribe on the YouTube channel. Yes. So we are giving you 15 seconds so that it's enough for you to go to YouTube and then subscribe. I'm also checking if I've subscribed. Okay, that's enough. Okay, so we can now start off. So my name is Dorcas, and I'm also learning this kernel developer thing. So I'm not very I'm learning with you today, and as Nanda said, if something goes wrong, that was the plan. It was meant to be like that. So what will happen is, just to give a quick overview of the session, is you're going to first start with like a general overview of what exactly like the Linux kernel is and where it actually falls. And then after that, we're going to now try and do a fast patch. And then now after that, we're going to continue. We're going to continue with the rest of the talk. So yeah, so if you have any questions, please uh, feel free to feel free to put it on the chat. And just, I don't know if Nanda can do a poll so that we just know the context of the people here. Can you please tell us if you have done the prerequisite? Like, there was an email sent out with some prerequisites to be done. I don't know if you've been able to do them. So, Nanda, can you please ask that you just see the audience and also the knowledge we have in C, what level you're at, and also I think just those two. You've done the prerequisites and also the knowledge, so that we just know how to go about it. Okay, the compiler is still compiling the test VM for Zeno. Okay, that's okay. It actually takes some time. It's not something that can do in like 10 minutes. It depends on your CPU, but when you do the compilation for the first time, it's a lot. So it may take time. Margaret, I'm curious to know. Martin, and the three others. Nanda said we were six.
Sorry, I was on mute. We are now 7.
Oh, we are now 7. So I just want to know where we are at so that I just know how to go through this. No problem, Eugene. We are just starting, so we're just getting context on what we are doing. Okay, no problem, Martin. Okay, I guess that's the most of it. So I'll just start, and then so that time does not go well. Does not go too much. If you see me look at the other side, it's just that I'm reading the notes that we have here. So I'm just going to I'm going to draw something on this screen to show like where the kernel sits in your Linux operating system. So you can be able to see my screen, right? Because I can see it, right? So we have the Linux operating system with whatever distro that you use. So how it's structured, like the operating system is a collection of different things. So the first thing that we have here is the first box here, like the base level rather. So here we have some firmware. Here has some firmware. We have, this is like, it's not even the deep of it, it's just like an overview so that you know where we are at right now and what we are doing. And then we are now just going to get into doing a patch. So we have the bootloader here, and then now we have the kernel here. So this is our kernel here, and then we have user space. So So each of these parts in an operating system have different functions and they have different users and they are programmed also differently. So we have the firmware. The firmware is actually what sets, it's like a set of instructions that controls the hardware. So when you hear people say, oh, I write firmware, it's just like instructions that control how the hardware starts up and how it interacts with the rest of the system. For people who have done like in Kenya, what's mostly popular is like Arduino. Like you've done Arduino, you're able to control some pieces of hardware here and there using the Arduino language or whatever. So it's like hardware and you're controlling it because you load now the code to the chip because uh, the Arduino has a chip. It's the Atmega. The Atmega, I think, I've forgotten the number, but the Atmega chip. So you load it there and then you're able to control whatever is connected to the board there. Then we have the bootloader. The bootloader is what is, oh, the poll has been generated. You can just fill there so that we can continue to know where we are at right now. And then we have the bootloader. It is what is able to load the operating system into the computer's memory. So if I was to restart my, at the end, when I finish, I'll restart, then you're going to be able to see the bootloader. Because the thing that happens is anytime you switch on your kernel, if you've done it, like when you switch on, you're going to be, there's a program that's called grub. So GRUB. So you can be able to select, like, because you see, as you continue with different versions of the kernel, you're going to have different uh, different boots. I don't know, like there are going to be different boots that you can select from. I'll show you at the end so that you can see that program. And then now we have the kernel. So the kernel manages like memory. It manages like the resources that we have, like the CPU, task handling, task processing, and all those things. Because you see, on this other side, we have hardware. The hardware is ready, and now user space is the apps that we use, like Google Chrome, this Streamer that you're using, whatever browser you're using. So we need something that's in between to control that. And I spoke before in my previous talk about the drivers that I was contributing to, and I explained where the driver sits so that it gives the instructions on how hardware is defined so that you can be able to have that communication. So like this is the general overview of the Linux operating system, and then where we are focusing on today is now the kernel, and you're going to see how to contribute to the kernel. So the kernel has different parts that you can contribute to. Actually, sometimes there are projects that focus on the kernel, and then there are projects that focus on connecting the kernel to user space. So they sit in between there. But now today we're just going to see how to submit a patch, because for you to be able to work on the kernel, you need to be able to know, yes, Clement said it at Mega 328p. Thank you, Clement. You need to be able to know the, I've lost my train of thought. I was talking about for you to be able to use the kernel. I've lost my train of thought a bit. But what I wanted to say is, you need to know to be how to send a patch. And a patch is just when you think about a patch, even when you think about a patch on a cloth, it's just like a fix. Like you want to fix something on something that's already existing. So it's like you trying to fix something on, like, to fix a piece of code or to contribute to whatever has already been built on the kernel. So that's the first step, because you might have thoughts on what needs to be improved, what needs to be done, or you're passionate about a particular driver, you want to contribute to it. That's when you need to do a patch. And so I'm going to go now to how we're going to do the first patch. There's a website that is pretty useful for anyone who wants to start contributing to the kernel. So it's called Kernel Newbies Outreachy Fast Patch. So here it breaks down every step that you need for you to be able to do a patch, because it's not that direct. It's not like, like on normal user space application, if you want to make a change, you just do a pull request and the reviewer reviews and your code is part of this. But here it's a bit different. You have to send a patch to a particular mailing list of a particular subsystem. So a subsystem is like, the way I said, like the Linux kernel is the one that manages resources that are available for the operating system, right? So for you to be able to make a change on the things that help in that, you have to submit a patch. And this is where we're at. And today we're just going to understand the tools that we need. And if time allows, you're going to be able to set up our first patch. So I don't know if someone has any,
Could you zoom in a little bit?
or you cannot see.
Yeah, or is it just me? I'm on a small screen though.
Are you able to see?
It's better, yeah.
Okay. So anyone who has a question? Okay. Okay. So this is where we're going to start. So the first thing that we're going to do, so a patch is like sending your Git diff, for those who have used Git before, sending your Git diff to the mailing list, so that, like, they can be able to compare, like, this was the state of the file that was there before, and this is the changes that Dorcas has made. So you send it to each subsystem. I was talking about subsystems. So because there are many parts in the kernel, like there are things that control file systems, there are things that control their drivers, there are people who do like the main OS, all those things. They are divided into subsystems so that they can be able to be managed. Okay, so it says, like, so when you send a patch, it's basically saying, like, showing so when you subscribe to a particular subsystem, it's like you're interested in that particular area of the kernel, and so you start to receive emails on changes that occur in that particular area. So at the end of this, we are going to leave you with some work for you to go over, so that you can be able to get a subsystem that you're interested in. I'll even post here, there's a good page that shows some projects that are open that people can contribute to. So the first tool that you can use, if you're using Linux, you can try to install Vim. If as a preferred code editor, you can edit your code on other places. So this is just setting up Vim. Yeah. So when you get time, you can just go and set up the Vim here, because I've already set mine here. So we have what you need to do, and it's highlighted here, how to set up Vim, so that you don't have to move between different things. Everything will now just be on your terminal here. Then the next thing you are going to do is to set up your email on an approved mail, approved email client. So I know like most people are used to Gmail, Outlook, but then what I'd say is people in the kernel get really frustrated when you send because what happens when you use Gmail, it stop posts. Like it's not very easy to follow the flow of a conversation with Gmail. So when you click this link here for approved email client, you're going to see the different email clients that people prefer. So the most popular one would be Moot because it's easy to set up, easy to send the patch, and it's very well integrated with Git so that you can send the patch well. So when you come here to the approved email client, it's listed all the good emails that you can use. There's even a part they have said don't use Gmail because the sometimes like the kernel is interesting. If you send using Gmail, it frustrates a few people. So do not use that. Like follow all these instructions so that you send the right email, the right format. Because you see, if you don't use this, the format of your patch is going to be a bit messy. So the one that I recommend is this one, Moot, which is text-based UI. It's not very
Maybe before you mention Moot, I can just add that normally what happens, it has happened to me too, like you forget. So Gmail has an option for sending plain text, which you can actually use. I sometimes use it for replying, but it works okay. But sometimes you might forget. Once you reply with the default editor for Gmail or any other email system, it will be HTML. And now the guys who are on text-based editor, they just see table, TD, TR. It's so annoying. So that's why, like, even you might be banned from some of the mailing lists if you're not
Yeah, you'll not
following
be
this.
bad, but they'll tell you what are you using, why are you using that?
Yeah.
Because but it's a common mistake with many people who start out because sometimes you actually don't know where to start. And maybe if you've subscribed to the mailing list and you're seeing people send things there, and maybe you even want to contribute or you want to say something, and then now you end up saying you end up sending whatever, because you see once a contribution is sent, anyone in the community can be able to give a review, give feedback, and receive feedback. So maybe you've been an expert in a certain field, or you've been passionate about a particular driver, and you need to and you want to give feedback on a change that they're doing. So it's very important for you to set up Moot or any of this. If you want a good graphical user interface, one, there's
You
Thunderbird.
can zoom in too. You can zoom in
Oh,
again. Yeah.
sorry. Here, let me zoom in. And we'll actually put up the mood config file because there are some settings that later we'll try and put the mood config file so that you can be able to configure mood also correctly so that you send the email correctly. So it explains here. But if you want a nice graphical user interface for sending email, you can use Thunderbird. Thunderbird is by Firefox. So that also sends well if you're replying to an email. I've never sent a patch with Thunderbird, I've just sent a patch with Moot, but I normally reply on Thunderbird, which is here. So it's also here. And yeah, it's explained everything. So that's why it was important for you to set up email, and then you have to configure the secure mail transfer protocol here. This is just mostly setup. And then now you have to set up Git on the terminal because when you do your patch, it has to be signed by you. So we have to know who has made the change. So that's why it's important for you to set up Git on the terminal. And it explains here how to set up Git. And then now we get to what is the main agenda of the day. Until now, is there anyone who has a question or who has had an experience with the terminal or not the terminal, sorry, the kernel, like anyone with a question before now we start to the main agenda of the day? Okay. I guess that means some of the typing, but if I see the question, I'll try to come back to it and answer it. So yes. So yeah. So we get now to the terminal. Here is my terminal. I have cloned my repo inside Media Git. And so we want to be able to follow the instructions on here so that you can be able to see. So this is just like the path that they have followed. So when I do my, unless you're going to be able to see the same files, like just a bunch, you can just go and read more on what each of these files do so that you can be able to know. Of course, here there are some files that I put myself that help me compile, like this git make, this shell script, and even this git menu.shell. Because you see, with Nanda, he put we did the basic way of setting up the kernel. But as you continue on, maybe there are some custom things that you want to do, there are custom ways you want to compile, so you can even just do a shell script for you to be able to do that. So we have been told to navigate to drivers. So you can see all these things are still there. So drivers, as I explained before, drivers are what sit between hardware and software. Because what I was giving an example, just to reiterate for those people who are not there. For example, if I have an application like this, I gave an example of Zoom. If I have Zoom and I know that Zoom is going to be able to use a camera, it's going to be able to use a camera that is in a laptop or even an external camera, and it needs to be able to detect like those cameras. So that is a user space application. That's purely software. Like as a developer, like as a software developer, you probably don't think about that. Just think about how does Zoom want to work? How does Zoom work? Because that's totally abstracted from you. And so we have the drivers there, which explain to software how the hardware is configured. So my computer has a camera, maybe camera XCH, something like just a random name of the hardware camera there. And then it's outlined or it's configured in a certain way, and it has different commands, it needs different voltages, and it needs, like, there are many things that it needs, but then my application does not understand that. So drivers kind of tend to explain to software what the hardware is doing, how the hardware is structured. And so they're normally like driver APIs that now help to govern even the developers of hardware. If I want my hardware to work with any software, so long as it follows this APIs, it's supposed to be able to connect to whatever software that needs to use this hardware that I have on this side. And so the change that we're going to do today is on a driver. So there are normally some test drivers that are found on staging. So it's explained to us here, like this is a kernel tree and all those things, and then it shows commit history, and then it continues to talk about a few Git commands that you can go through to know how to create a branch, da, 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 da. And yeah, so that branch tracks whatever you have. So let me even just see what branch I am on. So,
As you're doing that, just maybe I can interject a small thing, maybe just to mention.
yeah.
Of course, before you get to this, like cloning this repo, you have to choose your specific subsystem that you want to go with. But if you're not sure, you can just take the stable. So I've given the link there to the git.kernel.org. So if you check there, you'll see various trees that are there. So I'm sure even your tree is there. Your tree
Yeah,
is which one? Maybe just for the sake
my
of
tree.
completeness.
Let me just
Uh,
go there. Yes, I can see Zeno. Yeah, like that was a naming error. Like media git folder is not there. You should go to what should you go? Like just go to staging. I think let me go back there. The media git folder is not, because I contribute to the media subsystem. So I had created a folder called media git. Then I ended up cloning the repo inside that folder, and then I never renamed it. So that's why there's that. So
um,
sorry about that confusion. So when we come here, my tree, I'm actually like still under drivers. Like that folder is wrongly named. That's the point I want to put across. Yes, that's what I thought might happen. Yes, that's what happened. So I'm still going to go to drivers, go to the same thing. Like it's the same repo, but it's just that I named the folder, my local folder wrongly, and I just never renamed it. Sorry about that small confusion. So yeah, are we all together? Yes, hopefully. So yeah, in the private, yes, they have sent the tree here, and it has its history, but yes, more or less sharing the masterclass. So yeah, here we can go on to, so you create your own branch, and the branch I'm on was for testing. So let me just create a new branch. Sorry. Yes, Nanda has sent that.
Yeah, maybe as you're doing that, I just said like, so because there are many projects on, there's actually a good graphics. So if I get it, I'll share it. That just shows the various
I
trees.
think I have it. Let me
Oh,
check.
you have
But
it somewhere. Okay, nice. There's just various trees. So what usually happens is that every tree has the main maintainers, and then those are the guys who they take the patches from the contributors, and then they send them to learners for merging. So normally what has happened is that Linux has just automated. He has a bot that runs the merge. So as long as everything is good, it just merges and then says everything is good. Maybe I'll send. I'm gonna get one message that I can send. And what I love about this, everything is in the open. Even the messaging is in the open. The kernel mails, so you can always get everything. So I'll just send a few links here to the mails that you can see how a patch is sent. No, a pull request is sent to Linux for merging to the master or the next the whichever tree that. And now I think the tree that is tracking is it 6.12 or 13. I'm gonna send those links. I think I had one here recently. Somehow it does those on Sundays. I don't know, works on weekends. But anyways,
yeah, it's loading a bit, but yeah. Let me see. Do I have it? Here there's a link. Let me click that. Yeah, the thing about Linux, if you want to know anything, it's available. So now, how do I show this there? And how do I? Because it's now on a different. Let me try and um. Let me. It's a big diagram with all, like they've tried to explain all the trees and the mainland kernel. But let me just send let me just see if I can send the link. How do I share? Because it's on this other machine. I'll find out. I'll send it to Nanda, and then they can be able to, yeah. Nelson, I'm on the Mac M2. Can anybody recommend how to run a VM? I cannot. You can use VMware. I'm also using Mac OS, but you can use VMware. But setting up, because of the chip, because the structure of the silicon chips is I think it's 64. It's different. So you have to set up first Ubuntu server, and then after that you download the graphical user interface. It's not very direct to install the kernel on the silicon chip, on Apple silicon, but I'll send another link that I used to set up this. But with that, it's a bit different to set it up. You have to first do Ubuntu server partition. You have to do like partitioning everything yourself first, and then so that you can be able to have space for the graphical side, and then now you can be able to set it up. I'll put it there. But yes, you can use VMware
and
Fusion.
and by the way, we have, if you talk about architectures and this stuff, we have an expert in the room. So you better utilize him before the end of the call. Zeno.
Yeah.
Actually, he's worked even at Apple. So
Hey, Zeno can talk to us about it.
I wish he was on the stage. Yes. So, but
He would explain. Yeah, because yeah, as you said, like software support, it does suck. Yeah, I agree with that. So oh, I have not seen all this. Oh, it was the Nanda had sent it to the main chat because I was wondering. Okay, yeah, I will put the link of the tree. Like there's a tree plot here, and you can be able to see everything. It's too big. Sorry, and it's not on this device. Yeah. Uh, so I've created that branch that I need to create. These are things that you needed to do to update your kernel, and then you configure your kernel. So still explained here and showed the different distributions and where they are stored. Yes, and then finally you compile the kernel. Then I will move to the main agenda again, which is now how to make a change to the kernel. So, for example, we can just navigate to this path, which is this driver here. So, as you can see, the different drivers. Let me just go to drivers. Uh, there are so many. So, the particular driver I was working on was on the media subsystem, but we'll just follow the uh, things here. So let's go to that. Okay. I'm already in drivers, sorry. So let's go to net Ethernet. Yeah. So this is the path that was defined for us, and the change that they want us to make here. We have the different parts. So we have the C files, we have the header files, and yeah. So most of the time, yeah, in a normal structure, most C files have equivalent header files that define like the function prototypes that are there. For those who, Nanda, how did the poll do with C though? How did the poll do? You're muted. I cannot hear you.
Okay, I think we went to other things. Folks forgot about the poll. So, but the link, the poll, I'll send the link again. So only three responses so far, but maybe we can use that as a baseline.
Okay.
75% beginner
On C.
on
So
C,
two and then one probably.
25% advanced. I can guess
Okay.
who that is.
That's even
And
me.
then, have you
So
already set up the dev environment? Half of set up.
okay,
No,
that's it.
sorry, a quarter of set up. And yeah, so yeah, we still, and then on Linux Next, no one has patched the kernel yet, so but it's all good.
Okay.
That was out of the scope. Yeah, but
Yes.
if you can send your responses again, I'll share the link once more time. Uh,
And then
yeah.
Zeno has said we can remove the overlay URL so that you can be able to see that. So they can be able to see the whatever I'm showing. So anyway, this is just
Oh, sorry,
basically
sorry, sorry. Let me do that. And then, Zeno, if you don't mind, I've just sent you some DM on LinkedIn. Just you can just check. There's no other way I could reach you. So let me hide. How do I hide this quickly? Sorry
okay.
about that.
So yeah, this is just like the basic overview of a header file. You have to do some like here it defines like some function prototypes and also some constants that are defined here so that now they're implemented in the C file. So as you can see, these are just constants defined here for this particular module, which is the uh, Ethernet Intel E1000. So this is a particular driver. So it's a driver based on now the naming convention. It's a driver. It's a networking driver for Ethernet or something like that. I don't know because this is not the subsystem I'm on, but we're following those guidelines there. Yeah. So this is just for those who didn't know a bit of C. So just so that you know the difference between the .h and the .c. So probably for implementation purposes, you'd probably never do if you're starting out, unless you truly understand the details of those drivers. I don't think you'd change some things defined here, but maybe you would in case you're adding something on the other side. So all structs defined here, and then now they're implemented on the other side. So I'm just now going to go to which file are we supposed to change according to those instructions. We're supposed to change the main file .c. Uh, 1000, let's go main.c. So what line are we supposed to change? We need to find the probe function. Actually, yeah, It's an interest, like you should actually read on the probe function, because the probe function helps to set up when you're connecting a driver. When you're connecting a driver, most of the time the entry point of the driver is the probe function. So rather from the media subsystem, let me speak about the media subsystem. So like the driver, the entry point of the probe function, so it helps to set up, and then because there's a way that you have to order steps. Because you see, like with the driver, as I said, you're defining exactly how the hardware is supposed to, like how the hardware is supposed to function, right? So if, for example, but I'll open the prompt function on the media subsystem, then you're going to be able to see. But yes, I think like this was the entry point there. So we now need to search this, and then we just add this print line here. Just copy. So we search and probe. Sorry, that's not the probe function. E1000 device initially. Yeah, you see, this is the documentation part. It initializes the device and it gives that. So this is the function that you were supposed to look into, which is, I'm going too far down. So this is the function you're looking for. So this is the probe function, and we're supposed to add that line here. So I think it was after the first setups. Yeah. Yeah, so I can modify the kernel once you make any change. So we have not pressed escape. Escape, and then we have that. So we have written to that file. And it explains, if you don't know Vim, like this page explains explicitly, so you can't be able to do anything there. And then if you're on native Linux, it shows you what to do. So anytime you make a change, you compile so that you know if the kernel builds after your change. So now I can do, I don't know if I have a make file here. Let me see. I don't have a target here. So I normally, let me see. So now I'm compiling here. So anytime you do a change, you have to compile so that you see if the kernel is going to be able to build with your change. Because if your change has caused an issue, it's going to show there. The other thing I wanted to show you as this runs, so it's going to compile. It may take time because I've not compiled for some time though. And again, this -J, you don't have to put this, but this specifies the number of cores that you want to use. And I think it's been explained even in the tutorial that Nanda put out. Now, what I wanted to explain is there's a tool that we use in the kernel, because when you do a change, sometimes there's a way you have to format the code so that we make sure we write standard code. So I think it's part of the tutorial. Let's see. If changes, checking. Kernel best. Yes, this we're going to talk about check patch. So we're going to do this, and then I'm going to explain to you what this does, and then we recompile the driver. So right now we are at this point, but I think we can do that as we talk about it. So that we have the well-formatted code, like, because you see, let me just run check patch so that you see the type of errors that check patch can throw about the changes that you make. Yes. So there's a script. So check patch is like, so you run it as a script, and then you put which your target folder for check patch to run, and then it's going to give errors like indentation, white space, if there's a warning, if there's an error. So you have to make sure that when you do your changes, it does not reflect, like it does not add an error to check patch, because that means when the maintainer is reviewing your work, they'd have a harder time reviewing your work because it's not properly formatted. Most of the time, it's just like formatting issues. Because I think you're not supposed to have more than, is it 80 characters per line, something in those lines. So I'm just going to run it so that you can see. And with the kernel, we have to run with the strict, because it's a parameter that, like, it enforces more rules to be able to be checked for. So let me just do this. Let me just run so that I stop explaining a lot theoretically. So even before you compile, has it? Oh, it's still compiling, and I hope it does not take up the whole lesson. But let me do it here. So we were on drivers, and the driver we were on is net. So you have to specify the folder, and then if you go to Ethernet, I truly hope there are some errors on the files here, because you can run check patch on a particular file or even on the entire folder. So this one I can see it's running on the entire folder. Let's see, 1000. Yes. So yes, you see. So it's like, what do you call this thing? TypeScript linter, the linter on TypeScript. So it does that. So you come here and then you can see all the errors. Like, there are common mistakes that normally happen when you have like when you have, what do I have? The common things that people normally do when you have, when you define, not define, when you define unused variables, when you, there's a common one when the return is of no use, like you're returning and it's just whatever the uh like just some checks. So as you can see here, micro argument M may be better than M, precedence issues. So you can see it tells you if there are any issues there. And another good way to actually learn how to do a patch is to go to check patch, like run a check patch, and then try to correct these errors. So if you correct these errors and then now you send that patch, you're actually still contributing to the kernel, but you're learning to contribute, but you're actually doing meaningful contributions. So you can be able to see these things, unnecessary parentheses. Actually, this one is an easy one. So for those who've set up everything, you can try to correct these things for unnecessary parentheses. And this can be samples of fast patches. These are the fast patches that people do, removing unnecessary parentheses and trying to correct this. So for Zeno, who has deep knowledge in C, you can find something here that's not these small ones, but now, yeah, so these are the things that you can do. Yeah, unbalanced parentheses, it shows everything. So when you make a change, and let's say my change was on line, have I closed that? It's still compiling. Let me see. Let's see. Sorry. So we can see my change was probably on line, it was on line 934. So when you obviously when you do your patch, you don't know the previous check patch errors. If that's none of your business, you can just come and check. It's ordered in the number of lines, so you can see there's no error in line 923 here. So let me put an intentional error so that you can see. So for example, a common error is like if I put white space before. So let me just put white space here. It will show that. And if I put, I think, wait, let me just put that. So, because you see that's like a formatting error. And then I run check patch again. And that was on line 923. So you just scroll to the line, because you know the lines that you have changed. So I hope it detected it. Did I save? I did. Okay, maybe. Let's see. I don't think I saved actually. I did WQ, so let me see. Let me see. Let me see. Uh-huh. Let's see. 9:23. Oh, I did save. Okay, maybe I thought they were not supposed to be white spaces at the start. Let me see if I put here at the end. Let's see. Then here, sorry, not there actually, because there's an error for that. Trailing white space should be thrown. Let me see here. Mm. For some reason, it's not catching that error. I do not know why. I do not. Oh, sorry. I know why. Oh my God, we are in the wrong. Sorry, I know why. So I'm running checkpad in the whole folder. So I need to run for that. So we might be file one of this folder. So I need to run check patch for this particular file. Sorry. I don't know if we can I do check patch for, I think I can do check patch for a file. Let me see. Copy. Let's see. Yes. Now run for that particular file. So this was the person who created this check. It was just what is it? Yes, here it is. Trailing white space here. Yes, this is the error I was looking for. So you can see it's showing here. Here actually, this is the error. It's showing where the error is. So it just shows common errors and things that have happened. So it's important when you make your change, you look out whether the lines of code that you have modified have any results on check patch so that you don't have this. Yes, so that you don't have such errors. Because when you send this to a maintainer, you will receive the hit for it. So do not do that. Yeah, so I don't know if this is going to compile because I know I haven't compiled this for some time. And I pulled this today, so it's compiling all changes. Ideally, it's supposed to only compile the change that thank you, Nelson, for motivating you to contribute by just debugging. That is the point. It's not hard to start. Even my first patches were removing parentheses. Yes, and then now I started actively now knowing what I'm doing later on. So as you're learning the C, go and do those unused parentheses things. Oh, my time is running off. So what I will do then instead, because I know this will take time, uh, I will just show you how to make a patch. So we just keep that. So first thing, after you do a change, the first thing, run check patch to make sure your change does not have any semantic error or any common Linux error. Then after that, you do the make, because when you compile the kernel, if there's any error, you're going to catch it during that time so that you don't push errors. Okay, you don't send out errors because you never push to the mainline kernel. Then after that, we have like here, if you change something, it explains here. And then what I want to go into is to make a patch. So say you've already made a patch and you've committed. So let me go to my driver. Sorry. CD. So I was doing a test driver and it was called Vivid. So I know here I might have some changes. So let's see. Okay, let's take so I've just seen these are the changes on the tree, but even if it's not your change, you can still do a patch for it. So what ideally happens is now after you've done your change, you've made sure it's correct, you've compiled the kernel and you've seen it's good, you now have to do and you've committed your changes, you have to now send a patch. I don't know if I just stop. No, but let me just show you how to send a patch and then you can continue next time. So the command is here for you to send a patch. So I'll show you how to send a patch, but then now next time we talk about how your patch should look like, because sometimes you send a patch and people don't understand your patch. Not even next time, that's easy to talk over. But what I would say after it showed here how to do changes on Git, this is just like basic Git changes. Oh, how to commit. Actually, yeah, let me just go fast over committing, because this is different. Because you see, how we send patches on the on the kernel depends on how you have. I hope it will open something I've not added. So, oh my God, so much has changed, and there's very little time. I don't want to rush through this. I think we can pause and then we'll continue next time to see how to send a patch, because you see, ideally, your commit message, when I show you the Git log, your commit message is of a certain structure, and also
Mhm.
how you send the patch, the heading, like the heading part, the heading, the
The
header.
subjects.
Yeah,
Mhm.
the subject. Yes, the
Mhm.
subject is of a particular structure. So how you have to say which subsystem you're saying, which device you're doing, and then I think the best way to close it is if I showed you a sample patch. Let me just show you my sample patch, and then now I'm going to
Yeah.
talk about mm, how uh, how to send now that patch. So, and even patch versioning, because you see, like each patch has a version number. So, so it's okay. So, is this screen though? Is it coming? It's not coming to the side that I want it to. Sorry. Okay. The screen is not coming to this side, but let me just hold on 1 minute. How come I'm not able to drop a screen? I, what are you seeing on my screen? You're seeing this other screen, the patch.
Yeah, the
And
guide. Uh, but as you're getting the patch, let me just quickly do some. I wanted to request that for session 2,
mm-hmm.
because we're trying out this platform. It looks like you'll still need to RSVP, but I'll find a way of just seeing how I can add you manually, because I already have your details. But for the second session, what you could do, you could go over that outreachy page, and
Mm,
then you could come with questions like, okay, I tried this and it failed or something. Uh,
mm,
and that could be really nice if people can come with questions like, oh, what about these commit changes? What about the moot RC file and all that? I think it will be good. And then let us also know if you have any feedback that you can give directly here, or if you like to DM me on LinkedIn, or I'll also send a form to just hear of the feedback that you have about the session and how you like maybe what we can cover on part 2 next week.
yes, so let me, I have to unshare then share so that you can be able to see, because for some reason this is refusing to drop to my secondary screen. So let me just stop sharing and then I share a window. So yeah, so when you can see here, like this is normally this is just a simple patch that I was doing. This was, what am I sharing? I'm sharing patch 9. So what is that?
I think your Gmail.
Yes, that's because that's
That's
the
okay.
Gmail patch, because this is how it's going to come.
Okay, good.
So let me see. Patch 9. Let me get that. Yes. So yeah, so you're going to see, for example, you have to put like, okay, this will be done for, like, when you go through the outreach page, you'll see this part. But then what I wanted to say is you put the subsystem that you are working on. Or let me zoom since you cannot see. So you say I sent it to the Linux media and then a few people who are helping me, my mentors who are helping me with this. But then now you see you send, you have to put the subsystem you're working on, the driver you're working on, and then a short summary of what you're doing here. And then now you describe your patch. So next time I'm going to talk to you again about how to describe this patch, because as you can see, sometimes people would say this patch does this. I mean, if it's a patch, it should be obvious what it does. So this patch is not for you to say like this. So it's for you to give more context of why that patch is necessary. And then this is just like a sample patch. And then now, based on that's why I'm saying you need to put your proper sign off uh on Git, and then now it sends this. Because I remember what I told you, like a patch is just a diff of the changes you've put, what was there, what was not there, and all that. So this is just like now code for that as subsystem that you can see. I think that's it. I don't know if anyone has any question so far. Back to you, Nanda. Oh, even Nanda had sent the link here. So
Oh,
it's now.
I found that was your cover page, but I think
Oh,
I think you can talk more about it
let me
in the
click on
next
it.
session. Like,
Yeah.
actually, it would be nice to go over your patches and just maybe explain your process.
Okay.
Uh, and then now people can merge between that versus what they've gone through the outreach steps.
Mm.
Yeah, it was my work. So for me today, I was just like a TM, just to help with any questions or anything. And I'll still do my TA work by, I'll try to make sure that I record the setup, the screencast by this weekend, and send you. Like, if you just like to see from the basics of first getting a VM cheaply on Azure using the credits that you are given as a developer, and making sure that you shut down the VM after you're done. It can, the $150 can last you for the month easily. And then how now to set up one at a development VM and then another at a testing VM. I'll try and set up that screencast. Hopefully, to it will help. And then if you combine that plus the links that Dorcas has shared, I think next week we'll have a good time with any questions that you have, and you can let you go now with where you like to go with Linux. Yeah. Any questions maybe before close? Sorry, we've gone over by 2 minutes, but any questions? I know that don't worry if this was like drinking from a fire hose. Sorry, it's just a lot, but everything will become clear as we go. But I'll love you folks to come with questions. Like,
Yes.
how about this? How about that? But I know today you didn't have an opportunity because you're just getting this for the first time. But I'm
Mm.
sure now after this session you will have the questions. If you haven't seen the link, I can share it again. The link that outreach link to somewhere up here. Let me see if I can get it and just post it.
Oh, Nanda has disappeared. Um. Yes.
You
Oh,
know what?
he's back.
I just
You
okay.
click
It's
leave
funny.
leave studio.
Yeah. So anyone who has the outreach link, you can just post it on the chat, and then I will show it.
The can
Outreach, the one
you
that you be. Yeah, there, I found it. It's right here. So this is the link that you like. It's a one-stop shop actually for everything.
yeah.
Yeah.
If you do that, you're good to go. I was looking for, because I've seen like there are more experienced people here. There's a page that outlines many projects that can be contributed to. So like not just like fixing. Let me get that because it shows the projects in the kernel space, the projects in the user space, And the project, like, let me just put it here then. Those people who experience, like, Zeno can be able to check it out.
Denson has just said shameless plug. I'm assuming that actually Dennis, you worked there. Hook us up with the VMs, like yeah, but seriously, if you have any, like, where can we reach you, or anyone wants some VMs, that would be nice. Actually, even I'll rather do the walkthrough with that, with the Angani VMs, and then you are locally you have less latency. Actually, but then you can work from your, like, an Angani VM, almost like you on your machine. If you're in Nairobi or in Kenya, I guess the bandwidth is good. So Denson, let me know, please. Awesome. I'll get your email, I think, on the RSVP, or if you can just send me a ping on hey@nanda.dev would be good. We plan on Nairobi DevOps. Oh, good stuff. Okay, nice. Okay, folks, I can let you go and see you next Thursday. I'm not really sure about whether you need to RSVP again, but if you really need to RSVP again, please don't mind if I send you a reminder or a link to just RSVP again. I'm trying out this StreamYard option, and also maybe a quick poll. I would like just a quick one. Between this and Zoom, which one would you prefer? Because I was torn, actually. This or Zoom? Just say Z or S, StreamYard. Just on the chat, just Z or S. Let me see. Just quickly before you go. Okay, so at least you can talk. I could admit some people to quickly talk, ask questions, right? I think this chat thing is a bit like, yeah, Zoom. We have Zoom 1, StreamYard 0. The Zoom have it. StreamYard 1, 2, Zoom 2. Okay, let me just have 5 votes and let me. Okay, Zoom. So it means I'll send you a Zoom a Zoom link. Yeah. So okay, no, awesome. Let's do Zoom. I guess it will be more interactive. People can quickly ask questions. Okay, Zoom. Okay, the Zooms have it. Okay, stop now. The Zooms have it. Thank you so much. Have a nice evening or morning, wherever you are. Because I know Zeno is. I don't know where Zeno is joining us from, but thank you so much for coming. I hope you enjoyed the session. I did enjoy it too. See you next Thursday.
Come with questions.
Yeah. And also come
with feedback, by the way. And that will send a feedback form so that you know, because this is the first time we're doing this. And if anything went wrong, it was part of the plan.
Awesome.
Bye, guys.
All right, bye. Have a good evening or good day.